In this example, we're going to use elementary row operations to solve the system. Then I show you how to work with augmented matrix. So as you can see, you have 1, 2, 3 equations. And what are we going to do? We're going to add the first equation to the second equation. What's the algebra behind it? This is our first equation. We are referring to the original system. X minus 2y plus 3z equals to 9. And the second equation is negative x plus 3y equals to negative 4. And as you can see, when we're doing the algebra behind it, x and negative x, they get cancelled out. So you're left with y plus 3z equals to 5, which is replaced by the second original equation. Now you're going to add negative 2 times the first equation to the third equation. So negative 2 times the first equation, negative 2x plus 4y minus 6z equals to negative 18 plus the third equation, which is 2x minus 5y plus 5z equals to 17. Again, when you do the algebra, the variable x disappears. Remember that our goal is to get rid of variables one by one. And our third new equation is going to be negative y minus z equals to negative 1. Now what you can do, you can basically add these two equations and get rid of variable y, and you get 2z equals to 4. The rest is easy. We're going to divide the last equation by 2. Z becomes 2, and then use back substitution to find y, and then substitute z and y in the first equation to find the values. So as you can see, this system has a unique solution. Now, what if we want to use augmented matrix? When we look at our system of linear equations, the equivalent augmented matrix is 1, negative 2, 3, and 9, negative 1, 3, 0, negative 4, and then you have 2, negative 5, 5, and 17. Basically, all the coefficients along with the constant terms. What are we going to do? We're going to take the second row and the first row, add them together, and it's going to be our new second row. So R sub 2 refers to the second row. Then we're going to add the negative 2 times the first row to the third row to produce a new third row, right? This is what we exactly did in previous page for a linear system. Now we are doing the same operations on augmented matrix. Then what are you going to do? You're going to add the third and second row together and replace it for that old third row. It introduced a new row for us, which is basically 2z equals to 4. Then you're going to divide the last row by 2 and write down the system of equations equivalent to the matrix that you created. You can easily use the method of back substitution and solve this system.